Geometric series, or GPs, geometric progressions. In a geometric series, each term is obtained by multiplying the previous term by a constant r, called the common ratio. In general, we have a plus ar plus ar squared plus and so on until you get to the general term, which is ar to the n minus 1. Till we get to that general term of ar to the n minus 1. Notice on the second term there's 1 r, on the third term there's 2 r's, the fourth term would have had 3 r's, and so on. So for the nth term you've got 1 less than n, so you've got n minus 1 r's. So this tells us that the general term un equals ar to the n minus 1. We'll look at the sum of a geometric progression. We'll call it s. So this Sn here, s equals a plus ar squared plus all the way up to ar to the n minus 1. Each of these has all got an a, but they've all got r's in them. So it makes sense if we considered the term, it makes sense if we considered the series r times s, because that then becomes ar plus ar squared plus all the way up to ar to the n minus 1, and the last one would be ar to the n. The reason we're considering this one is because lots of these terms are the same in both series. So now I can consider the subtraction, rs minus s, and loads of these just cancel out, and I'm left with ar to the n, the last one on the rs, minus the a, the first one on the s. Little bit of algebra, factorise out the s, factorise out the a, I get s lots of r minus 1, and I get a lots of r to the n minus 1. I wanted to know the general formula for s, so I'm going to divide through by the r minus 1. So I get a r to the n minus 1 all over r minus 1. So Sn equals ar to the n minus 1 all over r minus 1. But that works nicely when r is bigger than 1. If r is going to be trapped between minus 1 and 1, if the size of r is less than 1, then we can swap around these brackets. We can effectively times top and bottom by a minus, and we get Sn equals a 1 minus r to the n all over 1 minus r. That one's a little bit more useful in these cases. The case when the size of r is less than 1 is when it actually converges. The case in the first one is where it's diverging. We'll look at an example, find the nth term of the GP, 3 plus 12 plus 48 and so on. Well, we can see very clearly the first term is 3. The common ratio, what you times in by to get from term to term, is going to be 4. 3 times 4 is 12, 12 times 4 is 48. So the nth term, we're just going to use our formula un equals ar to the n minus 1 to give us un equals 3 times 4 to the power n minus 1. We could tidy that up, but I'm going to leave it like that for now. Another example, find the sum of the first 10 terms of the GP, 5 plus 15 plus 45 plus 135. Again, very easily, the first term is 5. The common ratio, what you times in by to get from term to term, is going to be 3. So my Sn, I'm going to use, because r is 3, I'm going to use Sn equals a r to the n minus 1 over r minus 1. That gives us 5 lots of 3 to the power 10 minus 1 all over 3 minus 1. And now these calculations are a little big, we just get a final answer of 147,620. 147,620. Use the calculator for that. Thank you.